Mixed numbers are fraction numbers where you have a whole number part and then a fraction part. So you have the sum of an integer and a proper fraction, and you got to make sure that the little fraction part is proper, meaning that the numerator is smaller than the denominator. So when you see a mixed number like this one, the way that this would be read is 2 and 1/3. And that's the same thing as saying that you have 2 plus another third. So there's an implied addition in between these two numbers, and that's important to know. So let's practice converting mixed numbers into improper fractions and vice versa. So first way we're going to go is from mixed to improper. So I'm going to start by showing you how this would work with a picture, and then we'll see if we can come up with some sort of a little shortcut. So if I have 2 and 1/3, what I'm going to do, I've got these 3 circles over here. I'm going to cut everything into thirds. I just chose circles because I felt like circles. You could do any shape that you want, but we're going to cut these into thirds. And the reason why we're cutting them into thirds is because this language in the fraction part is thirds. So you have an amount of thirds. So if I take each of these and cut them roughly, pretend this is all like perfect and awesome. Cut those into thirds. See how I've got 3 holes? And what I'm going to shade is I'm going to shade 2 holes and then a third. So I'm going to shade all of this one, all of this one, and then a third here. Just a third. So I have 2 holes and then I have a third. So how many thirds did I actually shade? Well, 1, 2, 3, 4, 5, 6, 7. I shaded 3 of them and 3 of them and 1 of them. So 7 thirds. 2 holes and a third is the same thing as 7 thirds. It's just, do you want to write your answer as a mixed number or do you want to write it as an improper fraction? So there's got to be a shorter way to do this, right? We don't have to draw a picture every single time. And thirds, it's not hard to cut shapes into thirds, but still, it's kind of annoying to have to do a picture where we get 7 thirds here. So how could we come up with the 7 quicker? We had 2 holes and then a 1. So we had 3 thirds, 3 thirds, and 1/3. So the idea is the shortcut for coming up with the 7 is you go like this. And I've heard it called the popcorn method. You guys might remember this, but you do 3 times 2 and then you add 1. And see, it kind of looks like popcorn. That's why it's called that. So you multiply here and then you add there for this last little part. So 3 times 2 is 6 plus 1 is 7. So you multiply, then you add, and you keep the same fraction family. We were doing thirds for this whole thing. So the mixed number has thirds, the improper also has thirds. The denominators should always match, regardless of which form you're in, okay? So the reason why it's 7 is because we had 2 full circles, 2 of the 3s, see 3 and 3, and then we had 1 more on the top. That's why the shortcut works. So if we had another one, 3 and 5/8, that's how we would say this one. This one is all eighths. The fraction family here, as I call it, is eighths. So everything's going to be eighths. So even this improper fraction is going to be some sort of eighths. So I'm going to cut into eighths. Eighths. I don't even think I spelled it right. That's a hard one to spell. Okay, so if I cut these into eighths, there's 4, and then I'll cut it in half this way. So there's 4, cut it in half. Pretend like these are all perfectly spaced and everything's awesome. And I just have 4 holes because this is bigger than 3 holes. So I did 4 of them. And I want to shade 3 holes and then 5/8. So 1, 2, 3, 4, 5, whichever 5/8 you want. So how many eighths did I shade? Well, there was 8 of them, 8 of them, 8 of them, and 5 of them. So 8, 8, 8, and 5 makes 29. 29 eighths. And let's use our little shortcut here, our little popcorn shortcut. You multiply, then you add. So multiply, then add. 8 times 3 is 24. 24 plus 5 is 29. And it is, again, still eighths. The denominators should always match. So you can just use the shortcut. You don't have to draw the picture, but I think it's important that you see the link between the mixed number and the improper, and I think the picture does a really good job of explaining that. So now let's go the other way. Let's convert the improper fractions into mixed numbers. Okay, so if we want to go the other way, you literally just do division. It's like you take 21 and you divide by 4. So you go, well, how many times does 4 go into 21? It goes in there 5 times. 4 times 5 is 20, and you get a remainder of 1. So normally you would write R1 up here, but we're going to do this as fractions. So 4 divides into 21 5 times, and that 1 remainder, you write it as 1/4. Why fourth? Because the language here is fourths. So your improper and mixed both have to have fourths. So 5 and 1/4. Let me show you this in a picture. I'm going to use a different pen for this one. So I have to draw 21 fourths. So you can just do a bunch of circles. You may not even know how many circles you need. You just draw a bunch of circles. Like it doesn't even really matter. And the language is fourths, so I'm going to cut these all into fourths. Here's me cutting my circle they're all in fourths. I don't even know how many I'm going to need, but I'm going to shade 21 of them. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. Okay, so turns out I didn't need that extra circle. So there I shaded 21 fourths. How much is that? It's 5 wholes plus a fourth. I think you can really see it, and with kids, I think it's important, if you're teaching this to kids, I think it's important that you do the pictures along with the process. So 5 and 1/4, it's just division is all you have to use. Now the next one, the fraction family here is 25ths. I'm not drawing a picture for this one and cutting things into 25ths. Okay, we're just going to do the division. So 29 divided by 25. So how many times does 25 go into 29? It goes in there once with a remainder of 4, right? So R4, that's our remainder. So we're going to write negative, because this one is negative, see that negative right there, -1 and 4 25ths. Remember the language is 25ths here. And so you put your remainder over your fraction family there. So -1 and 4 25ths is what that would look like as a mixed number. Now one more thing we're going to do is we are going to add, but we're going to keep everything as mixed numbers, and we're going to practice adding without converting to improper fractions. It's actually, I think, easier if you'll leave them as mixed numbers and if you'll add them as mixed numbers. So I prefer, when I'm adding mixed numbers like this, to stack it up like I would whole numbers. So I'm going to put 5 and 1/4, and I'm going to add it to 2 and 5/8. And I'm going to stack it up that way because it's almost like you're lining up your place values. So I can add my whole number parts and I can add my fraction parts. The problem is you can't add the fraction parts unless you have a common denominator. So for these little fractiony parts, we have to get a common denominator first, then we can add them. So what I'm going to do is I'm going to kind of convert these over. So I'm still going to have my 5. But 1/4 and 5/8, what's the common denominator that we're going to want to use? Well, I think 8 would be a good denominator. So I'm going to make an equivalent fraction here so that this 1/4 is written as eighths instead. So what would I have to multiply the 4 by? I'd have to multiply by 2. You have to multiply by 2 on top and bottom. You get 5 and 2/8. That's the same thing as 5 and 1/4. And then I can add my 2 and 5/8. See how I've got common denominators there? It's going to add much nicer. So I'm going to get 7, and when I add 2/8 to 5/8, I get 7/8. So I get an answer of 7 and 7/8, and actually it wasn't terribly painful because I didn't have to go through and convert these to improper numbers. If you converted these, you'd be looking at, what would that be, 21/4 plus, what's that, 16, 17, 18, 19, 20, 21/8. And then you'd have to get a common denominator, and you see how big the numbers would get, and then I'm adding these huge numbers, and then I'd have to go and divide to make it a mixed number again. It's like, this is just not the way to go. You don't want to translate it out of mixed numbers and then go back into mixed numbers. Like, just leave it all as mixed numbers. Just make sure that the fraction parts have the same denominator and you can add them really nicely. Sometimes when you add the fraction parts, you will get an improper. If that happens, you'll have to convert that improper to mixed and add it into this whole number part. But as it stands, ours was good to go. It was just 7 and 7/8, and it was a fairly easy addition. All I had to do was one little multiplication by 2. So I would encourage you to leave it as mixed numbers if you can.